Hello everyone. Am I audible to you? Just let me know in the chat box that I'm audible.
Yes, you are.
Okay, thank you, sir. So, the Google Developer Student Club welcomes you all to this interesting, interactive, and intriguing session. GDSC is a university based community groups which are powered by Google developers for students interested in Google technologies. We are a group of 40 plus students having expertise in various domains, working towards creating events for the developers community and promoting STEM among the younger generation. We are the largest developer community consisting of 800 plus developers seeking expertise in Google technology. Moving on to cloud. I searched a bit for the statistic and this shows that 94% of the companies are now using are now using cloud services in 2022, and the graph is exponentially increasing. The global cloud computing industry has a market of around $480 billion, and as of predicted by 2023, it might even cross $600 billion. Cloud professions are in high demand, and as reliance on remote access continues to grow, so will the need for talented IT experts with specialized cloud computing skills like support, security, automations, etc. etc. So, if we grasp the above mentioned importance, we are here to cater our students with a month long Google Cloud program. I hope many of you were a part of it. It is about to end. And now we are delighted to announce its successful completion with ample of knowledge and practical implementations. To make the endings even more fruitful today, we are here with our expert session, Cloud in Opportunities. Our speaker, Mr. Anmol Sachdeva, is an international tech speaker, adjunct professor, tech panelist, a researcher who has publications in various domains. He is currently working in Google as hybrid cloud architect. Mr. Anmol has also completed his master's in advanced computing. Thank you, sir, for joining us. We are really looking forward to learn more from you. Without taking any longer, I now pass the baton of the session to our respected speaker.
Sure. Thanks a lot, Vaishnavi, for the introduction. I'll start sharing my screen. Please let me know once it's visible.
It's
Yes,
with
sir, it is visible.
Okay, great. All right. So, very good afternoon, all present, and a warm welcome. Thanks a lot for the introduction and thanks a lot for the opportunity. I'm really delighted to interact with you all, you, the bright young minds here, right? You have gone through some boot camp, gone through some of the trainings, and are looking forward to kickstart your career in cloud. So, we are going to have discussions around the cloud domain, the different opportunities that are there, how you can build a career in cloud, what all things you would need to do in order to have a solid background and foundation formed, and all of that is something which we'll be covering in course of 1 hour from now. Uh, so we will be using this deck for reference purposes. I'll be having a 10-15 minutes short introduction to what cloud computing it is at a very high level, because I know some of you are not exposed to cloud jargons. And this is where we will have this opportunity to get to understand some of the basic cloud technologies, and thereafter we are going to open an ask me anything session wherein you can bring your questions, any doubts that you have, anything could be related to cloud, could be related to any other career aspirations that you may have, and I'll try my best to answer your questions and doubts. Please bear with me during the session. I'm having a bad throat today, so I'm under the weather and you may hear some coughing and sneezing. Okay, so please bear with me for that and pardon me. So just to introduce myself, Vaishnavi has already done that, but I'll go one step ahead and talk about more of what I have done in the past. So I have been into this industry for around 8 years or so, and I've seen technology evolving. I have seen different phases of how cloud has evolved and have got kind of hands-on exposure on cloud technologies and distributed systems at scale. So I have even worked at companies which have handled thousands or millions of requests per second, which means the scale was really large. Now, just before we get into any of the details, since this is a session we are doing for Google Student Developer Group, it doesn't mean that whatever I'm going to speak is going to be related to Google, right? The thoughts will be my own, the opinions will be my own, and they likely will be very biased based on the experience that I have had in the industry and based on my own understanding of how the industry works. And all of that is getting driven through the experience that I have had in the past. And this is where uh, we will start on a note with how these different technologies work together, how the computing evolved, where we are today, and what's the future looking like ahead of us. And just for people who want to connect with me in personal capacity, you see this QR code at the top, which links to my LinkedIn and Twitter profile. Uh, and Yeah, feel free to connect with me regardless of which domain you are interested in. If you are interested in technology or research, feel free to reach out to me. So this is disclaimer. I have already discussed about this. So let's talk about the technological evolution. This is for the people who are really new to this field. Maybe you are in your first year, second year, and not very much aware of the jargons and terminologies or uh, the different terms that are used in cloud world, right? So uh, 50, 60 years ago, close to 1960s or 70s, there were these fleet of machines that used to be uh, kind of hosted in big rooms, right? So the rooms used to get filled, and these were really massive, gigantic infrastructure pieces which offered some sort of compute capabilities. And they were offering mostly central processing capabilities, which means these servers were individually working in solo capacity to serve a particular problem. So you gave a task to these computers or these mainframe systems, and then they processed it and they generated result. It could have taken a lot of hours to process because at that time the hardware capacity and the related resources were limited. So you didn't used to have uh, resources like GPU, TPUs. You were not having that big amount of storage back then. You were not having solid state drives, nor you were having any good uh, performance optimized hardware systems, right? This is where the first category of systems which started this technological trend was called mainframes. And till date, many of the companies are using mainframes. Uh, Examples of such companies, so people who are from banking sector, companies that are in healthcare and banking, many of them are having some traditional systems that are hosted in mainframes, and they are looking forward to migrate from mainframes to something which is more in line with the technological trends that are there today. Then in 1980s, we saw this boom of dot-com revolution wherein internet came. People started to have client server architectures. Now, client could be any machine which is requesting for a resource, and server is the one which is processing some kind of operations and then giving the results and serving back the resource to the client. So now here client server architecture really became popular, and we move towards a trend called decentralized or distributed computing. So from central processing wherein one machine was doing the task, one machine was processing the tasks, you move to a paradigm, a trend wherein client server architecture was being followed. A client could go and hit any server on internet, and the server would generate the response, give it back to the client. So this is how the client server architecture came into existence, and this is where the decentralized computing concept was born. And this actually offered clients to even have local compute, right? And this even enabled clients to have some applications hosted at their end, which didn't require specifically to interact with servers. So for some operations, you uh, interacted with servers. For some operations, you had them served through the client itself, right? This is where the client server architecture uh, came, and it solved a lot of uh, problems. So many of the use cases were solved, and people started to bring up IT services. Companies were born, companies like Microsoft, Apple, even like Google, Oracle were born. And this is where the actual internet revolution mainly started, right? Then we had private clouds. This is another trend, or this is another kind of ecosystem that came into existence in the early 2000s. This is where people actually were facing problems of elasticity. They wanted to have some compute which can be scaled, right? Since the companies were offering IT services and there were a lot of companies or clients which wanted to access those services, now the service providers wanted to scale out their operations, wanted to serve globally, or wanted to serve to wider audience, right? More number of companies. And this is where they started hosting large massive infrastructure in their personal capacity in some dedicated buildings or rooms, which they used to call as data centers or on-premises data centers. Now, these on-premises data centers again very much look similar to how these mainframes are looking. Even that could be a scary thing if I show you the actual image of how the hardware is getting plugged into and how this is actually powering global operations. But this is where, since infrastructure was really at a huge scale getting hosted, the compute power was massive, and people were able to scale out their operations on demand. And this is where the scalability came into picture, and companies started to automate things at both hardware and software level. And this is where the private cloud trend started in early 2000s, and people were even able to have remote access to the private data centers. So this is where uh, SSH came into and helped us with a lot of uh, use cases. So people were able to remotely access the compute uh, and infrastructure, and were able to perform operations by just making remote access. And SSH is one of the most common ways as to how it was done. And then companies started to think, okay, now we are service providers, and people are coming and asking for services. What if we try to have these services uh, hosted in some infrastructure, some capacity, so that we can sell this as a service to other companies, right? So the private cloud was very much in a private capacity. So if I am, say, a tech giant who is willing to serve its customers with a lot of products, then I would have my own private cloud data center and host these things, the infrastructure, the compute, the networking, the storage, etc., and try to serve my customers through my products, right? But what if I want to enable other companies to utilize this infrastructure to serve their own customers? And this is where the public cloud came into existence in late 2000s, wherein tech giants like Microsoft, Google, AWS, they started with a set of services. They started with having services like infrastructure, software, platform offered and sold to other companies, so that other companies can use them and then go about having their clients served, right? So other companies can utilize these products, can utilize these services, the cloud services, and have their products sold, or have their services sold to their own uh, kind of target audience, right? And this is where the public cloud infrastructure came into existence. Until date, we are heavily using public cloud infrastructure, and it is growing massively. So what in nutshell is cloud? So cloud, as we understand, is a shared pool of resources because it is being shared by different organizations, right? There is a vast or massive amount of infrastructure, massive amount of compute, massive amount of hardware that is laid out there, and it is spread geographically. So you have global access. So Amazon, AWS, Google Cloud Platform, Azure has Azure Microsoft has Azure Cloud, and all these services are essentially distributed globally, right? So you have presence in US, you have presence in Australia, you have presence in Asia, and whatever region you think, you will be finding a cloud service nearby, right? So these are shared pool of resources or servers, right, which are actually running software or data stores or some sort of network appliance, and these are hosted globally in data centers, as we saw, and are accessible over internet. So you, being a consumer of cloud services, can go and opt for services, and then once you opt for services, you can make use of them, create applications, and after the applications are created, you can serve through internet to your consumers. Now your consumers could be your mobile application users, could be your web application users, or could even be users who don't very much actively interact over internet, but sometimes for updates, etc., they want to utilize your services, right? So it can be an active engagement, it can be a passive engagement, but you are actually having your services hosted on cloud, right? And then these are metered services. So generally you actually are charged for these services. You have to pay for infrastructure because it's actual hardware which is getting hosted geographically, so it comes with cost, right? And this is where you have, for every call that you are making to a service, it is actually happening through a concept called API, or application programming interface, wherein you are requesting for a resource from a server, and the server is returning with the response depending on what information you have requested for, and all of those calls or all of those transactions are actually getting metered, right? So you are getting billed or charged for them. And then most of the services are also being offered in pay as you go model or pay as you go fashion, which means the amount of usage that you have corresponding to a service will decide your bill. But some of the services are subscription type services as well. So if you have to avail a service for a certain period of time, you will need to procure licenses, and it will say, okay, for $200 I'm sending you this service and you can utilize it for 1 year, right? So you can have subscription model or you can have pay as you go model, but mostly you will find pay as you go model being the most popular one, because this is where the cloud started. But as the cloud is maturing, as the public cloud domain is maturing, the vendors have started to realize that it's also good to have subscription models in place for people who have deterministic workloads. So if you say, I want to serve 12 billion calls per year because my workload is of that nature, then it's cost effective to go with a discounted price through a subscription model, which gives you 1 year package to serve 12 billion calls instead of relying on pay as you go, because you have deterministic workload, right? And this is where the subscription models come into picture. Please feel free to post your questions, right? This is at a very high level an overview that I am giving, which I'll be wrapping it up in 10 to 15 minutes from now, and then we'll be opening for questions. So please feel free to have your questions jotted down in the chat box. So this is how the data centers look like, and this is a photo of a Google data center on the left hand side. You see, you can relate to the color scheming, okay? And you already are seeing some pipes here. So you have some cooling mechanism, you have some racks laid out. All of these racks are really massive machines running hardware, and you will be actually catering to hundreds or thousands of customers through these racks, right? So you have this shared pool of resources. This is the meaning of shared pool of resources. So as we have understood what cloud is, and I know you are students and pretty much mostly you will be fan of pizza as well. So let's understand what cloud is by making an analogy to pizza, right? So let's talk about pizza as a service. So one fine day, you decided to go out with your family and dine out at a fine dining restaurant, and you wanted to order pizza. So here the green boxes shows the things which are managed by the pizza provider, the restaurant, right? And here the blue boxes that will appear shortly will reflect the services or the things which you as a pizza consumer has to kind of own, right? So when you go to a fine dining restaurant, you have pizza created using the raw materials like pizza dough, tomato sauce, toppings, etc. The infrastructure that is there, like the fire, the oven, right, where the pizza is baked, the dining table, electricity, chair, etc. All of that is provided by the vendor. So this is where you have a dining experience wherein you just go and you consume the services and you don't have to do anything, just pay the bill and get the services. Then there is another model, especially which got popular in the COVID times. You get your pizza delivered at your doorstep, right? And this is where you have to bring your own dining table, your own Coke, etc. But then rest of the services of how the pizza was created is taken care by the pizza creator, right? So let's take for example Pizza Hut, and Pizza Hut took the ownership of having all these services delivered. So you have a ready-made pizza delivered at your doorstep. Now you just have to bring your dining table, your Coke, and eat it, right? And you pay for the service. Then there is take and bake. So you decided that, okay, Pizza Hut is actually costing me a lot more. I'll have pizza created on my own. I'll buy the raw material from the market. So you bought ready-made sauce, you bought some toppings, you bought pizza dough, cheese, etc. So processed raw material you took, and then you brought up your own infrastructure, and then you went with having the pizza created, and then you enjoyed your meal, right? And then you said, okay, I'm going to build everything on my own, right? So you even prepared the dough, you prepared the tomato sauce, etc., and you went about having everything created at home and then enjoyed your experience. So if we see, these are the four models, right? The dine out, wherein you didn't have to pay, and where you didn't have to do anything on your own, and it was actually getting served from the pizza vendor. The pizza delivery service at your doorstep, wherein you had to just bring up some infrastructure or some specific requirements that you had, and you had to bring your table, your Coke, etc., but the pizza was delivered. Then you went with a model wherein you prepared the pizza by utilizing some infrastructure or some raw material, right? And then you prepared everything on your own. So these are how the cloud models of services segregated, and this is at a high level the categorization of cloud services. So the first pillar that we saw, which is dining out, is software as a service, wherein you are actually having a ready-made software given to you. You just consume the services like Gmail, Google Drive, right? You just go and consume the email services. You don't have to do anything special to consume the services. It's just a service which is getting offered. Either you pay for it or you don't pay for it, right? It depends on the vendor. Then there is platform as a service, wherein you are getting ready-made services, but then you have to define your application, your data, right? So you have to say, okay, I have the specific infrastructure with me. I'll write my application code and I'll provide the data that is required to run my application, and I'll be running my application as a service, which is platform as a service model. Then you get into infrastructure as service, wherein you're getting the raw infrastructure. You consume your infrastructure that is provided by the vendor. You bring in your application, you bring in your data, you tie the application and the data with the infrastructure. You have to certainly provision the infrastructure as well, which is getting offered by the vendor. And then you go about having your services hosted, and you enjoy by delivering those services to your consumers. And then comes the on-premises systems, the traditional systems wherein you are maintaining your own racks, you are maintaining your own infrastructure, you are the one who takes ownership of application and data, and you go about everything tied, right? So this at a high level is the XaaS, or as a service categorization of cloud models. You have software as a service, which is SaaS, PaaS, which is platform as a service, IaaS, which is infrastructure as a service, and traditional on-premises systems, wherein it's a private cloud capacity wherein you are working and you are taking care of each and everything. Even the hardware capacity is something which you are taking care of. So it comes with bit of limitations or restrictions, that if you are out of infrastructure, if you are out of hardware, you won't be able to scale, right? Certainly if you are over provisioning your infrastructure, you will be able to scale till some extent. But if your infrastructure is getting uh, kind of reached, right, if it's reaching its limit, then you won't be able to scale further. And this is where either you add more capacity in form of hardware, or you go and you look out for some other solutions. So the sources for this, there is a Google Cloud article that you can check out, and this diagram has been taken from a website called Optimizely. So at a broad level, the categories of cloud from a Google Cloud Platform perspective, most of the services that you will find will be infrastructure as service and platform as a service. So infrastructure as a service is a virtualized hardware, as I mentioned. So you are getting compute, you are getting RAM, you are getting CPU, you are getting storage, you are getting disk, and you are making use of that, integrating it with your applications, integrating it with your data, and you are going about having your services created. Whereas platform as a service is abstracted computing power. So we don't tell you that you have any infrastructure. The infrastructure is invisible to you. You just have a service platform, and you say, okay, I'm going to have my application, Java application or Python application hosted on this particular platform. You don't need to be bothered about, okay, whether the CPU or the RAM is going to be a problem for me. No, that's something which the cloud people have abstracted from you, and this is where the compute power is abstracted. You don't literally see the infrastructure. So infrastructure as a service, you will see the infrastructure. You will decide, okay, my application requires 2 GB of RAM and 4 cores of CPU, so I'll have to provision my infrastructure accordingly, and I'll have to bring up the compute instances accordingly. Platform as a service, you don't worry about that. You just say, okay, my application is this, it requires 4 cores, and the cloud vendor handles it for you. Software as a service, and this is where you are having services like Gmail, you are having services like Drive, wherein the software, the end product is actually getting delivered and you are the real consumers. Now, Google Cloud Platform has IaaS, PaaS, and supports SaaS. What means by it supports SaaS is you can have your SaaS applications created by using IaaS or PaaS, right? Because these are just abstractions, right? In order to have any application created, you certainly will require hardware, which will mean you will be requiring infrastructure as a service. You will be creating a platform of your own, or you will be utilizing a platform as a service offering from the cloud. So that brings in the pass. And then once you have created an end product which can be served to your consumers, right, or your audience, that means you are offering your service as a software as a service, if at all that is a case that you want to offer, or you can offer your own service as a platform as a service, right? And this is where you can host your solutions in something called a GCP marketplace. And this is where the solutions that are hosted on GCP marketplace are generally the SaaS software products, right? And then Google certainly has made a lot of acquisitions in the past as well for some of the products that are there in market. So some of the products are even of the category of SaaS. So this is where you even have SaaS as an overlapping concept. And all of these are just like different levels of abstraction. Anything that if you just at a high level want to understand how this is working, you just need to understand one simple thing, that SaaS, PaaS, IaaS, these are just buzzwords. At the end, you are having infrastructure hardware. You are defining some relation as to how this hardware should be used. You are defining an application. You are defining the associated data, or how the data should be created, how the data should be stored. So you are defining the inbound and outbound experience for your application with the hardware, and this is where you are having a product created and you're offering it as a service. Now, IaaS, PaaS, and SaaS are just buzzwords and some segmentation as to at what level the user sees what component, right? So SaaS, you will never see any hardware component, you will never see any application component. PaaS, you will see the application and data, and infrastructure as a service, you will see infrastructure, application, and data, all three, right? So this is at a high level segmentation done or segregation done, but underneath everything is using the same stack: hardware, application, code, and integrations, right? So nothing different is there. It's just about the matter of abstraction. Like you go about peeling the layers of onion, and you see, okay, the onion has a thin layer and then a thick layer, and then the thickest layer, the bulb in the center, right? So this is how it actually peels off. So at a high level, these are the service pillars. You have services on the lines of compute, on the lines of management. So compute will offer you the compute services, like uh, where you can host your applications. So virtual machines, if you are aware of, is one of the compute services. Kubernetes engine, which offers you with containerization capabilities, is one of the compute services. Cloud functions and app engines, which are of the category of serverless compute or function as a service for cloud function. This is another category. So FaaS is a pretty common term these days. You will find it AWS Lambda, Cloud Functions. These are the function as a service wherein you just define a particular functional kind of structure, and you say, I want this function to be executed on some event getting triggered, right? And this is where the infrastructure, the associated platform, etc., will be offered to you. You just have the function invocation happening and you get the results, right? So you don't worry about the infrastructure, you don't worry about the platform, you're just worried about the execution of the function. You pass the parameters to a function, you say, okay, I have to invoke this function, the function gets executed, it returns you the response. And this is where the serverless paradigm comes into picture for compute, wherein you are actually not at all having any access to servers, and this is why the name is serverless. You just define the function and the cloud takes care of it, right? And this is where the serverless paradigm comes into picture. So you have virtualization powered through virtual machines at a high level. You have containerization powered through Kubernetes engine. You have serverless powered through App Engine, Cloud Functions, or there is even a new recent offering, newly introduced offering, Cloud Run, which you can make use of, right? Then there are management services. So management has to deal with operations. So anything on the lines of logging, monitoring, CI/CD, anything on the lines of debugging, auditing, tracing, right? This is where you get the management services, and this is the second class. Then there is networking. So anything to do with virtual private cloud, how you should be having your IP address management done, how you should be having your connectivity established between different clouds. So generally, it is seen that people have started understanding that not every cloud is good at everything, right? Or it could be that some cloud providers are offering a set of services which are really distinguished services. And as a consumer, you may want to leverage some services from GCP, which GCP is good at. You may want to leverage some services of AWS, which AWS is good at. You may want to leverage some services of IBM, some services of Azure, some services of Alibaba, and so on, right? So now people have started realizing, and companies have started realizing, that it is very rare that you have a cloud which is offering all the services in the manner you desire. For a consumer, a cloud may be offering a set of services which are good for its use case, but then the same set of services may not be enough for solving a specific use case for another customer. And this is where some different cloud provider could be offering more mature services or more coverage in terms of the service offerings. And this is where people have started uh, dealing with a scenario wherein they want to use AWS along with GCP. GCP will solve some specific use cases, AWS will solve some specific use cases, and this is what we call as multi-cloud. So multi-cloud is essentially when you utilize multiple public clouds. Okay, and this is where you will find these days companies are moving towards public cloud, and by the time you graduate, you will be in a situation wherein you would need to have expertise in not only one cloud but multiple clouds, right? So as a takeaway from this session, the first takeaway is to be a generalist from a cloud perspective, understand the core services, understand how compute works, understand how databases works, understand how networking works, but don't really stick to a specific cloud vendor. Okay, so this is the first takeaway. Be open to explore the multi-cloud ecosystem, right? The second takeaway, companies have legacy systems. As I mentioned, banking clients are there, healthcare clients are there, or regulatory companies are there which have strict security requirements or which have strict regional requirements. So maybe your data should not be escaping the China region, or maybe your data should not be escaping the European region, because European countries have laws like GDPR. Chinese companies have laws like the Chinese cybersecurity law, right? So you have data residency, which means a data should a data information bit should not be escaping a certain geography. So Europe related data should remain in Europe. It should not go to Americas, right? And this is where the data residency requirements are there, regulatory requirements are there, security requirements and compliance requirements are there, wherein you would even not want to host your data on public clouds. Okay, so this is where the traditional on-premises data centers come into picture, and you have private cloud capacity for hosting your applications. But then some applications of yours may not be bounded by those data regulatory requirements, compliance requirements, security requirements. And this is where for those applications, you may want to still leverage GCP cloud or still want to leverage Azure cloud. And then we come to a situation wherein the private cloud is getting used along with public cloud, and the public cloud could be a multi-cloud scenario. So this scenario wherein private cloud along with public cloud is getting utilized is called the hybrid cloud scenario, right? And this is what is getting reflected through my title as well. I'm a hybrid cloud architect, which means I deal with on-premises as well as multiple clouds, right? So this is the first takeaway for you. If you are aiming or aspiring for a career in cloud, it's not just about understanding or getting hold of specific technologies of a specific vendor. It's more about understanding the foundations, understanding the pillars, understanding what compute essentially means, what serverless means, regardless of whether you are using cloud function or AWS, it doesn't matter, right? So you need to understand what all the core infrastructure components mean, how you can leverage these core infrastructure components to solve a specific use case, and how different scenarios can be solved by combining these set of services or these pillars, right? So compute is one of the pillars. Management, as I mentioned, it relates to operations, logging, monitoring, management, etc. Then you have networking, which empowers you with IP address management, how the appliances or the servers should interact with each other, how you should be having some security enforced, maybe using firewalls, maybe using some service parameters or controls or boundaries that you may want to form around the services. Then there is a class of storage and databases, and I would generally term it as data stores, because you could have different storage mechanisms. The storage could be on the network file storage system, could be on the hard disk, on the SSD, on persistent volumes. And then there are data stores like BigQuery, wherein you get to host your data in close to infinite capacity, right? Because when we are talking about cloud, it's more about we generally use the term infinite, and this is where you have to carefully choose this term infinite. And many a times I have seen students understanding cloud as an infinite shared pool of resources, wherein you think you could go upon spinning indefinite number of virtual machines, indefinite number of data storage. But that is not true, right? Because ultimately at the core, the data centers which are powering the public clouds are also constrained by the hardware limitations. And it could be that you are specifically in US Texas region wherein you are hosting this hardware, and you have only 10,000 virtual machines which can be uh, powered by the Texas data center. If you want to create 10,001th virtual machine, then probably you will need to go to Montreal or Dallas or some other particular region, right? Because the number of hardware resources that were there for Texas have already exhausted. And this is where the concept of quotas come into picture, wherein the cloud providers have quotas associated to their services. So they say you cannot have more than 10 virtual machines being a client hosted in the US region, right? And I'm just creating a hypothetical example because they want to cater hundreds of thousands of users, and each user would be requiring virtual machine in Texas, let's assume. So they don't want a particular user to go rogue and acquire all the virtual machines or procure all the virtual machines. They want to have a fair game for the users, and a fair chance for the users, wherein each user should be at least getting some access to Texas virtual machines. And this is where the concept of quotas come into picture. The cloud hardware keeps on getting expanded, but then for some brief amount of time when you have limited hardware, the quotas actually help a lot. So this is again a very critical thing to understand when you get about stepping into cloud. I have seen people spending a fortune on services like AWS was pretty popular back in days when I was graduating. And I've seen people go about not paying attention to quotas, not paying attention to metered usage, and they turn up their system and they don't bring down their cloud services. And many students ended up having thousands of dollars come into and reflect in their billing account. And then they said, okay, I didn't utilize the cloud service, how is it even getting built, right? This is where your systems are getting built at least per minute, right? So every minute at least your systems are getting build, and this is where the metered usage thing comes into picture. So you have to pay for the amount of usage, at least if you have not bought any subscription model, right? And when you generally go with free trials, or when you go with credit card based trials, you are in a pay as you go fashion, wherein though you are not actively utilizing a resource, but you have procured some infrastructure, and the infrastructure is getting reserved for you so that you can utilize that infrastructure. And this is where you get even charged for that particular infrastructure, right? So this is a very critical thing to understand. Then you have some more big data capabilities that are there, and these are some of the offerings. You have identity and access management. So why identity and access management is really important is because every user who is accessing the cloud services needs to be identified, right? So if I am going about having services utilized from GCP needs to know that I am Anmol, and I have some unique identifier with me, which is going to be my email ID, and I am using these services so that I, I can associate the billing, I can associate the privileges, I can associate some security policies with this particular person. So the concept of uniquely identifying a particular resource who is trying to access your services is dealt through a concept of identity and access management. So IAM is a field in cloud itself. And this is where you can even go about having a career pursued. And many companies are offering specifically IAM specific roles wherein you have to take care of identity and access management of their systems and cloud. And then machine learning services, I think this is pretty much a buzzword these days. So at least you are aware of some machine learning services. If you go one level deeper, because that was a really high level thing, you can go to Google Cloud Cheat Sheet. And this is where you will find even more categorizations and service pillars and the set of services. Mostly, it's pretty much a comprehensive list and keeps on getting updated. This is maintained by DevRel community at the Google. So let's try to get into the zone of question answers, and I'll have a few things which are some of the most common questions which people generally ask, which students generally ask, and then we are going to move into more specific questions once we wrap up these 3-4 slides. So let's talk about the prerequisites required for getting into the cloud career. So first thing, which is something which is non-skippable, right? You cannot bypass this at all. And people do have notion that uh, we are cloud architects, so we are cloud engineers. We don't need to program because it's different from software engineering. No, right? Programming is really the core of cloud computing. Programming is really the core of anything that you do in technology. Okay, so programming and coding are the two things which you have to understand. You have to have a good grasp, and this is where even my suggestion would be to not directly jump with a career in cloud if you don't have any software engineering exposure. So as a student, you should be focusing on at least having a few internships or have some associate level or junior level software engineering jobs done or taken uh, before moving into cloud domain, because it's pretty logical if you think from a rational perspective. You are trying to deal with cloud services which are already abstracted, and you are telling that you are going to be an architect or you are going to be an engineer who is going to propose solutions and going to create architectures for scalable applications, and then you don't understand the core of how the applications work, how the applications are built, right? And this is where, if you don't know how the software is getting built, how you can have an architecture specific to hosting that particular application created using cloud, right? So in order to understand how best the architecture should be created for hosting your software applications, you need to understand how the software engineering is actually done, and this is where the programming will help you, right? So programming is the first pillar, non-skippable, no doubts. Please go for it. Don't ignore it. Have some internships done, have some junior level jobs focused on before actually stepping into the cloud career. That would be my personal advice. Many people would say, and many companies are actually promoting cloud engineer, cloud architect level, even for freshers. from my personal experience, I can tell you that could be disastrous. Okay, so don't just ignore this. This is very serious advice. Have some programming, software engineering exposure, build some applications, could be mobile applications, could be web applications, but at least do some software engineering. Could be front end, could be back end. I would say if you get a mix of both or a full stack engineering role, do take it, do pursue it in form of internship, and significant amount of internship. I'm saying at least like 6 months of period wherein you are investing time to understand how the system works, and then go about procuring or having a job, and at least spend like 2-3 years in the job. And after 2-3 years, once you have understood how the software engineering system works at a high level, because even software engineering is a field you can go on studying for your life, whole life, right? So 2-3 years you will have decent exposure with how the systems are working, be it web engineering, be it mobile engineering, and then you can now think of stepping into cloud. But then the preparation for stepping into cloud has to happen during these 3 years which you are devoting to software engineering. And this is where the other concepts come into picture. So web engineering, it's pretty important. One of the core things of getting into cloud, everything that you do today is happening over internet in some fashion, right? Everything that you do today is happening over some distributed system. And when I say distributed system, it is essentially a set of services that are getting offered by a bunch of servers, right? So you need to understand computer networking, how the protocols work like HTTP, TCP, because this is where the exchange between the servers with related to data would happen using the protocols. And you need to understand the data exchange formats. You need to understand the representations of data like XML, like JSON. So you need to understand different protocols and the representations of data and how the systems actually communicate with each other, because at the core, it's servers interacting with each other. Now, one server can act like as a pure service provider, and one of the machines could act like a client in that particular case, right? So this is where the machines actually are interacting with each other, regardless of whether they are hosted within a cloud or whether they are hosted over the internet. It doesn't matter, but all of them are following some web engineering principles. They are using some protocols. They are having some data exchange standards defined, and they are actually having some specific representations for their data. Then comes data stores, because no application can survive without having data stored, right? So you have a category called data stores. Now, data stores could be databases wherein you are actually storing your data, could be, and databases could be further divided into relational databases, which are maintained in form of a tabular format, and then there could be NoSQL databases which are broadly classified as schema-less databases. Again, you are going to study about RDBMS or relational database management systems, at least during your college, if not NoSQL. And then there is another category which is trying to merge relational databases with the NoSQL. So combining the best of schema-less and the schema-oriented databases, which we call as NewSQL. So this is again not a very popular term. By the time you graduate, it would have picked traction. So NoSQL, NewSQL, and RDBMS are the three things which you should be focusing on from a database perspective. Then data stores are much beyond databases. So you have queuing systems like Kafka, like message queuing systems, RabbitMQ. So assume a case wherein you are trying to access a bank application and you are trying to make a transaction. Now, everyone would have made transaction, be it with bank system or be it with some e-commerce application like Flipkart or Big Basket, wherein OTP or one-time password is required. Now, when you have to make a transaction, you are generally shown a one-time password, and that password is getting delivered through SMS or through email at your system. And then you enter that password and you get access to the transaction, and you make the transaction successful if the OTP matches. Now, how this OTP is getting generated is through some queuing mechanism. So you have created a request that I want to make a transaction, okay? And then the transaction generates some event or generates something because of which your request goes and is kept in a queue. Now, queue essentially is going to be kind of emptied. So the requests that are getting formed in queue. So you are having the first request, then some other customer may have another request. So the requests are getting pipelined in a queue, and there is a set of servers that are consuming the data from the queue and then processing those requests from the queue. So this is where you may have even experienced that sometimes it happens that you have requested for OTP today, but you are getting your OTP delivered maybe a day after or a week after you have requested for it. And this is where the queue lag was pretty much, there was a huge line in the queue, and your request got to the server and got processed by the server after a day. This is where, in order to make reliable services, you just cannot have systems wherein you are waiting for the response, right? So you have generated OTP and you cannot keep on waiting for that particular response. So you fire the request and you have it enter into queue, and then server in its own time, depending on how many requests are there, will process your request and return the response to you. Now it could be that by the time the response is returned, you already have a timeout done at your application. That is something for which you will need to again request for OTP. But then this is where the queuing system is coming into picture, wherein you are actually making your services more reliable, because the user at least doesn't have a service crashing. Or sometimes it could be that you may want to have the service response which is not time critical sent to customer. This is also where you can have the queuing systems utilized. Then you have something called as caching systems, wherein the frequently used data is essentially cached. And when we say cached, it is hot data which can be accessed without going and doing the full round of processing. So let's say you created a request for having index.html page of your website served. Now index.html page, let's say it has some data associated which gets refreshed every week. Now if you have millions or billions of customers who are accessing your website, you won't want the server to again receive a request, go to the database, fetch the response from database, then form the index.html page and serve it to the user. No, what you do is, for the first request that is getting made to the server, it performs the cycle of going to database, getting the response, having the response formed in the index.html page, and then it stores index.html page copy in some system which is called as caching system. And then whatever requests are coming subsequently will actually go to the caching server, instead of having your server engage, instead of having your databases engage. This is where you save on the processing power, and your server and database could actually be utilized for some other operation. This is where you even save cost. This is where you save the number of transactions even. And there are certainly some more details to it, but I cannot cover all of them given the time duration. But essentially, to give you a gist of that, I explained. So web engineering is really, really important. Data stores are really important. Caching, message queuing, data warehouses, which are used for machine learning, data analysis, etc. The databases, SQL, NoSQL, new SQL. These are all really essential, and these are essentially the services which power cloud. And then you have operating systems. So I would just recommend you to stick with at least Linux systems, because those are highly used when you make critical applications. I'm not denying the fact that Windows servers are also used, but Linux is something which is very common and which is highly utilized, and you will frequently encounter Linux more than Windows servers. So these are the prerequisites, and this is where, when you are spending time at college to understand things, to understand systems, you should be at least focusing on these areas, if not all. So how to break into cloud computing, or how to break into your career, which can shape you and which can take you to the cloud career kind of position, right? So first thing is to understand that needs to be understood is, you need to build a portfolio. You need to have some solid projects or contributions made, and we have a dedicated slide of building a portfolio, so I'll expand on that particular thing in the upcoming slide. You need to make some open source contributions, and Git is your friend. If you are not aware of Git, generally you don't get exposed to Git in your college. You should be getting exposed to Git, and you should be having version control systems or source code management explode, because there are some open source projects or projects which are freely available with their code base in the open source, which essentially will give you an understanding of how actually software engineering is happening, how essentially you are having interactions done with cloud services, if at all those projects are using cloud services, how essentially the programming is helping to solve a specific use case, and how the team collaboration happens, right? So how you work with multiple people on a large scale project. This is where you will get exposure to uh, all of these things. So I would suggest you pick any open source CNCF project. When I say CNCF project, it is Cloud Native Computing Foundation. Why cloud native? Why I'm suggesting this these projects is because CNCF are set of services which is offering a set of services, or has a set of services which so it's a body, right? It's not owning any service. It is just having a combination or a collection of services which it is referring to as cloud native computing services. And this is where services like Kubernetes, your data stores, your open source projects, many of the open source projects are hosted. So you will get to understand distributed systems and how these systems work at scale. Most of the systems are actually powering massive organizations or massive scale of organizations and operations. So I would highly recommend to make open source contributions, and for that you will need to understand how Git works and how version control or source code management works. Then there are summer of code programs that you should be participating in. Again, it's very difficult to get into considering that number of people and applicants have been growing in the past. But these are some good to get started: Google Summer of Code, MLH Fellowship, DigitalOcean Hacktoberfest. There is Outreachy program, then Season of KDE, and there is Linux kernel mentorship also if you are interested. Girl Script Summer of Code, Ruby Summer of Code, Rails Summer of Code. So there are many Summer of Code programs that will give you exposure on some decently sized projects. You will be making contributions. You will be exercising your open source contribution aspect also there, and you will be actually contributing to community, because of which you will be building a strong portfolio for yourself. Then you should be aiming at undergoing some internships and boot camps. And two of the most popular ones, again, like not popular ones I would say, but two of the uh, kind of relevant ones I would say, which not many people know about. One is Digital Product School, wherein you actually get to experience a team collaboration at a remote site like Germany. It's a residential program wherein you will be mentored by people from companies, tech giants like IBM, BMW, etc. And you will work on some specific problem. You will have some students who will be labeled as software engineers, some students will be labeled as MLAI engineers, some students will be labeled as program managers, etc. And this is where you will form team. Each team will be having one software engineer, one program manager, one MLAI engineer, one database engineer, etc. And you'll be working on a product. So this is a really good opportunity, really good exposure from a networking perspective, from a mentorship perspective, from an opportunity perspective. Uh, and essentially there is another program, Inno School, which does the same. These are again Europe based, so it's a residential program. So you will need to travel to Europe and take this. In the COVID times, they have done it remotely as well. So that's not an issue if you are just concerned. And don't hesitate or don't think twice before applying if you are really interested in getting good exposure. And if and they even do give stipend, so that's a good thing. And you can even do internships at startups, at companies. So AngelList, if you know of, Let's Intern, Internshala, these are some of the websites through which you can get internship opportunities. InstaHair. So these are some of the websites which you can utilize to get internships. And I would strongly recommend, once you enter your third year, like go about hunting your internships. Don't wait for your semester to start. It takes at least 7 to 8 months to land even an internship. So if you are aiming for getting an internship in the third year, start applying towards the mid of second year, and then you will be able to land up internships at good places. And generally the applications at big companies also open 7 to 8 months prior to the actual internship date, because they have to go through interview process and they have to cover a lot of documentation stuff. Then participate in hackathons and codathons. So these are competitions. There are some online hackathons, codathons as well, which are organized by sites like Top Coder, CodeChef, Hacker Rank, Hacker Earth, etc. But then there are many in-person campus oriented hackathons and codathons organized by professional companies. by companies like even Google, HP, etc. And this is where you really get to build on some products during a time constrained duration. And this is where your problem solving, your innovation, your collaboration skills would actually come into picture, and you will be building something using the cloud technologies, because at that time you won't be interested in building everything from scratch, which means you will look forward to utilizing some of the services that are already available. And when generally people come to hackathon, they utilize cloud services, and this is where you will get exposure. You will try to solve some specific use cases, and mostly the hackathons are organized around some specific themes, so you will get to understand the theme as well. So someone will say you build something around solving the problem of cabs, right? Or someone will say you solve the problem of healthcare, you do something novel with the AI ML. And this is where you will come up with some novel ideas, and you will try to merge them utilizing the cloud services and build your product. And this is where you will be getting exposure, and this will also reflect in your portfolio. And then professional certifications do matter, and we will have a discussion about the professional certifications, good to get started certifications, etc., in the upcoming slides. Project ideas. So building a portfolio. So I would say portfolio is a really wide term, and it can be domain specific as well. So firstly, you should be identifying which domain you are interested in, whether it's web application, whether it's mobile application. It really doesn't matter whether you are doing web application or mobile application. At the end, at some point of time, you will be required to have cloud services utilized, wherein your web application is having a client and it is having some APIs fired. You are having the actual processing done based on the data that you are giving, and you are supplying through the API in the cloud. The cloud will produce result, and you will serve it to the customer. So it happens with web applications, it happens with mobile applications, and it really doesn't matter whether you choose web application or mobile application. At the gist, or at the core, you should have your portfolio project utilize some sort of data store. Could be database categorization, again could vary, cloud NoSQL, SQL, or new SQL. You should be having some APIs hosted on cloud, which means at least host some servers, some services, some applications in cloud with which your client can interact. Have some load balance services in the cloud. So try to think about how I can reliably run my operations. How can I run my operations at scale? What if instead of 10 requests that I'm receiving today, if my app gets popular and it's deployed on Play Store, I start receiving hundreds of millions of requests? In that particular case, you will need to go and strategize how your infrastructure should scale in cloud, and this is where the load balancing schemes come into picture. And also there are some auto scaling mechanisms also that you should be exploring. Then you should be also focusing on operations, so logging and monitoring, because anything and everything that you do has to be tracked. And for visibility purposes, you need to have some sort of logging of metrics, or logging or monitoring of different areas and components done. This is where the logging monitoring service comes into picture. Have some continuous integration, continuous deployment. Again, this may sound as an alien term to you, but it essentially is moving towards automation, wherein you try to automate a few tasks. Maybe you are building a software, so your software should be going with some unit testing, some integration testing. So this is where the CI/CD pipeline, as soon as you are committing your code on Git, that code is taken, some tests are run against it, and if the test pass, then your application is deployed in your cloud servers. And this is what CI/CD in a nutshell is at a very high level. And then you should be focusing on some security mechanisms, like having your authentication and authorization fit into your application. So no user which doesn't have a client credential, username, password associated should be able to access your services. So in a nutshell, when you are forming applications, when you're building portfolio, an application should have some database components, should have some set of servers which are interacting with databases, should have some load balancing mechanism, should have some CI/CD automation, should have some authentication, authorization, and logging monitoring. This is where if you build a couple of applications around this theme, regardless of whether it's mobile or web application, you will be getting a good exposure in cloud, and that will be getting served as a good example for your portfolio. And do believe me, it really helps you understand the system and distributed systems at scale. Then containerized applications, it's another I would say technology these days. I won't be getting time to explain this further, but If you have heard about Docker, Kubernetes, this is something which is related to that. So virtualization, containerization, I'm just giving you two words. Go and study these terms, what these mean, because cloud essentially started with virtualization concept and it got realized because of virtualization concept and the hardware abstraction. And then we have recently got introduced to containerization as a concept, and this is where we are hosting applications in a containerized format, and this is where you should be going ahead and learning more about this. But if you are able to build something on the lines of containerized applications as part of your portfolio, that would be even great. People interested in AI ML, I would say, don't run behind the jargons. Don't get very excited when people say AI ML is the future. No, web applications and applications, the mobile applications will still continue to exist, and web application, mobile applications will be having integration with AI ML capabilities. So you will have an application which will demonstrate or exhibit some AI ML capabilities, right? It's not that AI ML is a concept on its own and it will work without any applications. No, at scale, when you are actually productionizing your systems, you will need some application to even host your AI ML logic, right? Chatbots, cloud on embedded systems, people who are interested in IoT, who are interested in Arduino, Raspberry Pi, you may explore some edge services, cloud services. So these are some project ideas. These are themes, I would say, right? And then you can realize these in terms of ideas. So maybe you can build an e-commerce application, you can build some healthcare system, you can build some record system, you can build some chatbots, etc. So these are themes which are general themes, but if you build projects around these themes, you will actually be getting a lot of exposure and you will be creating some good value for your portfolio. If you are not getting any idea, as I mentioned, drop into a hackathon. You will get a theme, you will get some partners, collaborators. Those collaborators could be totally unknown to you, and then you can go about working on some particular projects, and that is where you will start understanding how the project themes are actually placed and what essentially it takes to realize your applications and your projects. Coming to certifications, so foundational level certifications, and these are like some GCP certifications and non-GCP certifications, but equivalent certifications exist in other clouds as well. So at a foundational level, if you don't have any technical expertise, Cloud Digital Leader is an exam that you should be taking, and you will be finding the preparatory material, etc., at the links that I have provided to you. Do feel free to reach out to me over LinkedIn in case you have any other questions or if you want some more detailed plan for preparation as well. Then after you are done with foundational certification, which doesn't require much of technical exposure, you can go with associate certification, and associate certification will be getting started at a junior level, how the cloud resources work, and this will be more or aligned towards using the cloud commands, how the cloud services are used, and it's not going to be a real architecture based certification. If you want to move into architecture based certification, which is more of advanced level certification or a professional level certification, there is professional cloud architect certification, and this is where I would say once you have spent 2 to 3 years in industry, once you have understood the software engineering paradigms, once you have gained some understanding of cloud systems and built some applications in your portfolio, after 2 or 3 years of experience, you should be attempting for professional cloud architect certification or any professional certifications, and those could be even domain specific certifications like professional database engineer, DevOps engineer, data engineer, ML engineer, network security engineer, etc., and many more are there which are linked here. This is about the GCP certifications, but as I mentioned, infrastructure as code, and this is something many of you would have got exposed to when doing the cloud skill bootcamp from Google Cloud during this particular program. So infrastructure as code, Terraform is not the only tool which helps you with infrastructure as code. There are many other tools that are there and competitors of Terraform like Pulumi, Crossplane, config controller, etc. But Terraform is something which offers certification and is a very good starting point for students. So this is where I would say there is a Terraform associate level certification that you can take once you have got some internship exposure and you have explored Terraform in your own personal capacity. And then you move towards CI/CD automation and DevOps certification. So GitLab certifications I have linked to, but there are certainly other certification providers based on the tool that you are using, like Jenkins. If you are interested in DevOps, there is a a private body, DevOps Institute. So you can go about having DevOps certifications as well taken from there, or you can go about searching for DevOps and SRE certifications, and you will find some bodies providing them as well. So this is from a certification perspective. And before getting into Ask Me Anything QA, the last section, what are the different career aspects, how you should be, what are the different job roles that you can apply to when you're moving into cloud. So one role which comes to our mind, and it's pretty intuitive, you are working from a software engineering background, or as I mentioned, you should be starting with a software engineering background and you want to bridge a gap between software engineering and cloud engineering. So you move with a cloud engineer role wherein you get to exercise maybe some cloud automation using infrastructure as code. You get to build software using cloud technologies. So that is the cloud software role. Again, companies interchangeably use the terms, and sometimes companies may refer to cloud engineer as a cloud architect or cloud consultant as well. That is totally up to the companies. But at a high level, the segregation that I'm providing you, engineer is actually focused on even programming. Okay, an engineer would deal with software, would deal with automation, would deal with operations, the logging, monitoring, maintenance, management operations. Whereas an architect would be focused on the high level and the low level designs, how the components work, which programming language works best for the particular use case, whether you should be going with a relational database or a non-relational database, what all trade-offs are there from an optimization perspective, how you can have the cloud cost optimized, how, what services are right for your particular architecture, if you have a specific use case, what all security network requirements are there, all of those things. The low level as well as the high level design is something which architects take. An architect, becoming an architect does require you to have a cloud engineering exposure. That's my personal experience and that's my recommendation. So if you are aiming for a cloud architect role, first be a software engineer, then be exposed to cloud engineering, and then be focused on cloud architecting. So because software engineering along with cloud engineering will give you good amount of background and good amount of foundational knowledge for applying those things in cloud architect. If you have not at all worked at software level, if you have not worked at how the operations work, the management works, the maintenance works, how will you be even able to comment anything from a design strategy perspective? So people generally get into this trap that companies are advertising roles of cloud architect for freshers, but they don't understand that one cannot sustain if one doesn't have software engineering and cloud engineering knowledge, right? So this is another takeaway. Don't just focus on ambitious job roles. Just build your foundations the right way, and then you will find a ladder which you will start following on your own. So everything will be streamlined, everything will be put to path. Software engineering, cloud architect should be your path if you are exploring from a high level. Don't directly jump to cloud engineering, cloud architecting or cloud engineering without having software engineering as a prerequisite. Cloud consultants, these people even have and even cloud architects have to understand business requirements instead of just technical requirements. So cloud engineering people are very much focused on technical requirements, but cloud architects are also focused on business requirements along with technical requirements, because they have to shape technical solutions around some business use cases, right? So if you are from automobile industry, you will have to shape your solutions which suit the automobile industry. If you are from banking industry, you will need to have your solutions shaped according to how the banking solutions work, because every solution or every industry would have different set of requirements, right? Then you go about cloud consultants. So cloud consultants are people who have at a high level breadth and depth of the cloud technologies, and they can propose solutions for you. It's kind of a have overlap with cloud architect and engineer, but these people generally don't do much of hands-on from an engineering perspective. They are kind of a high level blend of architect and engineer. uh, and then we have domain specialists. So as I mentioned, when you are becoming an architect, like you start with a generalist approach, or maybe you could start with a domain specialist approach wherein you are focusing on network, you are focusing on storage, you're focusing on databases, etc., right? So you can go with domain specializations when you are becoming a cloud architect or an engineer. Then cloud support jobs, people who support by with solving customer related queries. If you are into a services organization which is providing a cloud service, a set of cloud services to the customers, these people generally go about having understanding of services and help resolve or troubleshoot customer issues. Researchers, so people who actually are applying their brains to build these cloud services in the back, from a design perspective, like high performance, how the high performance computing can be done, what different mechanisms I can have in my database layer so that my database is efficient and optimized, right? So all of those things are jobs of researchers, and these are limited in number, I would say. And you won't find many advertisements for research jobs, but these are the people who are actually building the distributed systems, and then the cloud vendors acquire the knowledge of from these researchers, maybe through the research papers that they have created, or maybe at companies like Google, at companies like Microsoft, there are teams of researchers who work and bring these technologies and build new technologies and drive innovation, right? And then you have some product and engineering team who take their ideas and implement these things, right? And shape it in form of product. Cloud service consumers, so you can be the end consumers of cloud services, so you can be software engineers, application and mobile developers, etc. And you can go about having these services created, which utilize cloud, right? That is not a pure cloud engineering role, but that is where the cloud software angle comes into picture. And then there are semi-tech roles as well, wherein you require some knowledge of cloud computing, you require some knowledge of technical things, but then program managers, product managers, business development managers, which probably help service companies build products around cloud, or maybe have customer engagement driven. So maybe if I'm at Google, I'll have a team of business development managers who will drive uh, some engagements, who will bring customers who want to adopt on cloud, and I'll help the customers. So this is where the roles like business development managers, program managers, product managers, technical program managers, etc. come into picture. So now I am opening for question answer session, right? Ask me anything. I think we planned for wrapping this in 15-20 minutes, but again, I got driven by the things which I wanted to include, just so that it's beneficial to you all, right? But I think, yeah, we can extend by 5-10 minutes, even if like people are interested and they have questions, right? So I'll pass it over to Vaishnavi for bringing up the questions that are there in crowd.
Thank you, sir. And as for the questions, I guess people have started uploading them in the chat sections already.
Okay.
So, yeah.
Okay, let me see. Uh, okay. Uh, okay, question from Mukal. Do you see cloud computing as a service that will eventually replace traditional computing hardware for regular consumers? The answer is no. Why? Because as I already mentioned, there are customers, there are companies who have regulatory requirements, who have requirements which don't allow them to have a shared infrastructure, right? So you want to have a complete isolation, and this is where even cloud vendors are offering you shielded infrastructure and reserved racks, that this particular infrastructure piece will not be utilized by a particular organization, but only you. These are the kind of infrastructure kind of offerings which the cloud vendors are coming with. But many people are hesitant to go with cloud providers when they have strong regulatory requirements. Like banks would prefer to have some systems on premises in their private cloud capacity instead of going with public cloud, just because they don't want the data to escape their infrastructure, or they would want to go with some regional regulations or data residency requirements. So this is where I don't see at any time cloud being the de facto standard. People will still go about having private and public cloud, and this is where the hybrid cloud is really shining out these days. Then there is a question from Santosh: can working professionals be part of GSOC? I think, yeah. Until this year, it was not possible, but recently GSOC has announced that even working professionals can participate, and I think I even made a post of this on LinkedIn, if you check my LinkedIn profile. So if I'm recalling correctly, now working professionals can even participate at GSOC. Then we have Jethwa with a question: is CISSP in cloud preferable after a job as a software development engineer. Okay, yeah. So CISSP is essentially a cybersecurity certification, a security professional certification. It's I would say, as you have mentioned, is it preferable? It depends whether you want to pursue a career in the field of security. If you are not interested in security, it's an optional thing, right? But if you want to pursue in field of security, like knowledge gained is not something which will not benefit you, right? So even if you are having a cyber security and security professional certification, uh, that really will help you in understanding and even developing more secure solutions for your clients. So this is where I would say, if you have inclination towards security, just go and opt for it, right? uh, then we have a question, Mokal, how to build cloud projects around cloud technologies while staying within budget. Okay, this is a very good question. Staying within budget. So I already quoted an example wherein I have seen people spending hundreds of thousands of dollars because they didn't focus on. So this is where you need to play on the uh, cloud FinOps perspective. FinOps is essentially financial operations aspect of cloud, wherein cost optimization and management comes into picture. And even you need to be, if you are a good architect, you will be aware of cloud economics as well. So cloud economics is a dedicated field of its own, wherein you understand the different economical and financial factors influencing your cloud architecture. And this is where uh, cloud vendors offer with you with some mechanisms which you can utilize to stay in budget. First thing, if you are doing pay as you go services, if you're going with pay as you go services, don't opt for and don't get driven by that notion of infinite infrastructure. So I have seen people spin up 64 GB and 32 core machines just because they got excited. Okay, I don't have 32 cores on my laptop. This is where I'll utilize my cloud and I'll spin up a 32 core machine and I'll exercise some machine learning workload on top of that. No, this is where you need to be very cautious about the decisions that you make regarding your hardware procurement. So even going with a CPU of 8 cores would be able to train your model instead of going with a GPU or TPU, right? And you certainly don't need to go about having a 32 core machine, because you are not breaking or making innovation or really innovative thing, right? It's just a side project that you are doing mostly in most of the cases, and this is where you don't require infinite capacity as such. So just be cautious about the hardware that you choose. Then there are sustained used and committed use discounts that are available. So if you are not in on free trial, you can go with sustained use discounts or committed use discounts, wherein you will be shown, if you are going to utilize your this particular service or virtual machine for 1 month period, then you can have a discount of 20% also, or X%, right? This is where the committed use discount comes into picture, or sustained use discount comes into picture. And sustained use is essentially, if you keep on procuring the services for a longer period of time, the cloud recommendation engine would tell you that since you are an existing user and you continue to use our services, we are going to offer some special discounts to you, right? So this is where the cloud vendors have these schemes. Then you certainly, when you are bringing the virtual machines, there is a concept of preemptible and non-preemptible virtual machines, or spot instances as well, right? This is where you should utilize these cost dynamics and FinOps techniques. Go with spot instances if you have a workload pattern for which you don't have a deterministic workload or TPS or volume, or even go with serverless or function as a service, wherein you just invoke a service when you actually have a request corresponding to that, and you don't need to spend anything on the infrastructure, right? So choose for or opt for such concepts, opt for such cloud FinOps techniques, which can help you kind of curb the cost, right? And then certainly, I would say alerting and monitoring on your billing is essentially a really good thing that you should be following. So go about having some segmented alerts set up. So once you are about to hit your billing budget maybe you have passed 50% of your billing budget. Maybe you said that you decided that you will not go beyond $200. Once you have hit $100, have first alert. Once you have hit $150, hit another alert, and then have another red zone alert hit when you are towards $180, so that in time proactively you can go about taking a decision on whether you want to continue or whether you want to control the cost in some specific manner using the FinOps. So I believe that answers your question, Mokal. Then you have another question. I think Ankit Sharma also had a similar question. Jetwa also had a similar question. Santosh has a question. Do you suggest Google Certified Fellow certification for someone who has 9 years of IT experience? The first thing to understand is fellow certification is not something which is a kind of certification. It is essentially uh, a position wherein you have already covered the domain specific certification, the domain specific cloud certifications, right, or professional certifications. So if you are able to cover all those 11 12 certifications that are there under the professional belt, then you become a certification fellow. Many people are behind passing the certifications these days, and you may have seen this grow on LinkedIn as well, that I am a fellow certified professional, I am this, I am that. That really won't help unless you have that into application. So if you have gone ahead and had a database engineering certification, that could be just because of rote learning that happened behind the scenes. You could have gone through some dumps, you could have gone through some books for that particular period of time, maybe for a 1 month duration or 2 month duration, because of which the concepts were really fresh at the time when you attempted for exam and you were able to crack the exam. But then once you disengage from exam, in a month or two's time, everything is lost. So try to get onto a track wherein you are actually exercising the concepts and you are building something, so that it stays for you for long, stays with you for long, instead of doing a rote learning or going with a short stint of just passing the certification. So I would say, if you have a mindset to just create some personal brand around certification and you want to offer some certification related guidance, it's totally up to you. But don't go with the rat race and just focus on applying concepts rather than chasing certifications. Having certifications do matter when you are approaching a job, but that is when it would make sense if you truly understand the technology and are able to exhibit and demonstrate those capabilities as well. Because if you enter a job of database administrator or database engineer, and just on basis of certification and because you had those concepts fresh for the last 2 months based on the study that you performed, but in the actual real world you are not able to solve problems, you are not going to be an asset for the organization nor for yourself, right? And you will certainly need to make move or switch gears and get into some other domain, or maybe do everything again from scratch and be a good database engineer, right? So just don't get into that trap. People will come up with posts, will give you some offers that, okay, certification discounts are there, maybe you are getting some free certification trainings, etc. But those will look lucrative, but don't get into the trap unless you have a set path or dedicated roadmap planned for yourself and you really want to delve deep into the domain. Then we have a question. I don't, there is some number here. Can we get a job as a fresher in Google for cloud engineer role? If yes, what are the expectations and the requirements for the job role? This points back to the thing which I mentioned as to why you should not be getting into a cloud engineer role as a pure fresher. I would say there are roles, there are available roles which are there. You can check on LinkedIn as well. There is Google Career Portal wherein you can check the roles, and I know there are roles because many of the roles are open in my team as well. But I would say don't again go with pure cloud engineering role as your first step if you want to be a good engineer and architect in the long run, right? Do spend 2 to 3 years of time as software engineer and then only come to this field. In the meanwhile, try to build your portfolio, try to exercise cloud software skills, try to exercise cloud engineering skills, and develop your main core, your understanding, right? But don't directly blindly apply for cloud engineer role, because that will put you in a situation where you are going to stagnate your growth. After 1 or 2 years in the role, you will feel pretty much exhausted from the content coverage that you have had, but you won't have any dots to connect back to the software engineering domain. And then again, that will be a learning curve that you will need to go through in order to sustain in the industry. So if you want to pitch from a long run perspective, aim for software engineering, then cloud engineer, and then after 5 or 6 years of experience, cloud architect role may still suit you. We have a question. Okay, I think that was answered. So over to you, Vaishnavi, if there are any other questions that are left unanswered.
Thank you, sir. I guess
Yeah.
majority of the questions were posted in the chat box already.
Mhm, mhm.
I think we will go with a final call. If anybody is having any new doubt, then just make sure you ask it now.
Great.
Also, sir,
Mhm,
there were few questions that were
mhm.
that we got from the Q
Yeah,
and from the session that we have asked for
yeah,
you before the
mhm,
session. So
yeah.
one of the question was there from Aditya.
Mhm,
So he is asking, when should we start working for the certifications, like in the 4 year
mhm,
of
mhm.
engineering journey, if we
Yeah,
wanted to.
that's a good question and very well placed for this particular session. So thanks, Aditya, for raising this concern. Uh, Cloud certifications, as I mentioned, right? As and when you have some internship experience, I would say you should start parallelly working on the foundational and associate level certification. This is where the things which you are learning from your internship would really come as practical experience to which you will be able to relate during your certification preparation, and you will be able to apply back some of the principles learned through your certification preparation in your internship as well. So as and when maybe you are in third year and you have already got into an internship, or regardless of whether you have got into internship or not, third year is good to start with foundational and associate level certifications. Why? Because by that time you have covered database prelims, right? You have covered operating systems, you have covered basic computer networking, if not advanced computer networking, right? So these three core pillars are already covered, which form the basis of the certifications, and this is where you can start diving into the foundational and associate level certification. So I would say third year, after covering operating system, databases, and networking as the three pillars, and certainly programming, as I said, is a non-skippable thing, you should be focusing on foundational and associate level certifications. And by the end of fourth year, when you are entering the job market, if you have an associate certification with you, that will be really beneficial and will reflect very good on your portfolio.
Right. I hope Aditya's question got cleared. So I have a question out of curiosity, as
Yeah.
you have explained also. Like
Mhm.
as someone who is exploring cloud since last 3 years, I have I have faced different confusions in different roles that the
Mhm.
cloud domain offers. So you
Mhm.
also explained about the cloud architect, that he is someone who will also build the technical solutions along with focusing on the business part.
Yep.
But yeah, as you are working as someone hybrid cloud architect, so
Mhm.
I just wanted to know what is your roles, especially in
Mhm.
working at Google.
Sure. Right. So I'll be not discussing about any sensitive details here
Yeah.
because this is like a external forum, but I'll give you pointers about what my role looks like so that you have an understanding of the things that I generally deal with. So my role is essentially about helping customers, clients of Google Cloud Platform to build solutions that are scalable, reliable, and efficient, optimized from a FinOps perspective, that may be aligned towards some specific technologies like data store technologies or big data technologies or emerging technologies like high performance computing infrastructure or containerized solutions, etc., right? So it's essentially my specialization is in infrastructure and emerging practices. There are dedicated teams for data, AI, ML, even for infrastructure and practices like containerization, hybrid cloud, for which we have a platform called Anthos, if you are aware of that. So there are different teams within our kind of broader team, and there are people who focus on different technologies. But my background prior to Google has been of site reliability engineer, so I'm able to relate to data stores because I have efficiently managed data stores at scale of millions of requests per second. So I am pretty much into distributed systems, emerging technology, and even from my master's experience, my master's was in advanced computing, which actually was a culmination of 4 or 5 specializations. So soft robotics, bio-inspired AI, applied data science, high performance computing, human computer interaction. So a lot of diverse fields which are futuristic and which will come into realization maybe in 5 or 10 years time. So this is where I'm able to relate to different sets of technologies, but my role is primarily focused on infrastructure and the hybrid cloud technologies like Anthos, API management, Kubernetes, application modernization, migrating from monolithic or monolithic to microservices architecture. So everything around infrastructure and application modernization is something which uh, my role generally deals with. And being a hybrid cloud architect, I do get to build solutions for public private cloud or collaboration of these two fleets, right? So it's not very much restricted to Google Cloud only. We also have solutioning done for customers who are having footprint in Azure, AWS, and Google Cloud, and we help them understand how Google Cloud and AWS related bridge can be formed and how they can cross utilize the capabilities, etc. So this is what my role looks like: infrastructure and application modernization mainly.
Okay, actually, I really got a great insight by understanding your profile, because I really wanted to know this question, like how the customers, if they at all they wanted to shift their cloud
Mhm.
provider from Google Cloud to AWS, how they work. So this is one of the great insight I got. Actually, this was a really a great session I've attended so far, and as I'm someone who is like exploring Google Cloud since last 3 years, and
Mhm.
have been attended sessions so far, this
Mhm.
is one of the great sessions in which I've got a lot of insights and a lot of takeaways about the projects, and also about the certifications. So thank you so much for it.
Great.
Yeah, over to you, Vaishnavi.
Thank you, sir. So, I guess we will be ending with the last question for today,
Mhm.
and it is a question by our Google Cloud students. So,
Okay.
basically, now they are done with the fundamentals and they have
Mhm.
some basic knowledge about these services. They
Mhm.
have attended many theoretical sessions, and now they have done some physical implementation as well. So,
Yeah.
what ahead now?
Okay. Great. So I would jump back to the place wherein I talked about building portfolio and building ideas, right? The actual projects. So since you have now gathered good information from a theoretical perspective, and also I think you were exposed to some hands-on labs as well, wherein you got to explore these utilities and products in individual or solo capacities, right? And now is the time to go about having some integration done. So you will be creating some servers which will be hosting some APIs. So maybe you have written a Python application with Flask or Django as a framework, and you are exposing some REST APIs to start with, right? I'm not talking about any advanced API patterns like gRPC or streaming APIs. Just focus on small building blocks. So focus on building some REST API using framework like I have taken example of Python. So Flask or Django or Fast API, whatever you pick as a framework, have an application created with get, post operation, put operation, delete operation, and have it exposed or hosted over a server, and have those servers load balance. And then for whatever post calls you are making, have the data stored in some local storage, maybe in files to get started with, and then eventually move to utilizing cloud services like Cloud SQL or Spanner, depending on the use case, and maybe make use of some caches, make use of some different data stores that are available. And then for those services that you have exposed through cloud servers, try to have logging, monitoring, and the related operations tracked, right? For which sometimes you will be required to install some utilities, and sometimes you will be required to have some dashboards, visualizations created, some alerts set, some notification channels created, etc. And then once you have created this application, now try to do something novel wherein you are having a CI/CD integration done. So maybe pick up GitLab, pick up Cloud Build, pick up any CI/CD provider, any open source platform that you may want to opt for, and then go about having some new APIs added to your server, but those APIs you won't be deploying. The code that you submit in Git needs to actually get automatically deployed after having some test cases. So now for fast API framework related application that you have written, write some unit test and have the unit test invoked as part of the CI/CD pipeline through the CI/CD flow that you have built, so that the new changes that you are doing, that you are committing over Git, are essentially getting deployed as well on the servers, and then try to have those served from these servers using load balancer, etc. So when we talk about load balancer, certainly there will be an aspect of associating some domain name with the load balancer as well, so that you are able to hit the services from some external party, right? So this is where, when you get into building the projects, you are not going to just work on individual product offerings. Instead, you will be working on realistic architectures. And this is where I'm saying you can go with web application, you can go with mobile application, it hardly matters. The thing which matters is you are using a bunch of different cloud services from different service pillars and trying to integrate and have them serve as the foundations for your application. So have application code, have data. If you have these two things, try to serve them through servers. When you have to serve them through servers, now automation and reliability and scalability aspects come into picture. So you should be thinking about load balancing, you should be thinking about auto scaling, auto healing, how to have logging operations, monitoring operations, how to have automation done. And once you have done all of this, you can move into security posture, wherein you can say, okay, for accessing this application, now I will only allow users who are authenticated and authorized for this particular application. And this is where you explore some of the security aspects as well. So I would say, for the people who have already gained theoretical knowledge, it's time to build out some projects. These projects could be something which may be your own idea, or could be ideas coming out of collaborations that you do at hackathons. And once you have done, or you have passed this particular stage, then is the time you can start making open source contributions, and then everything will fall in place.
Thank you so much, sir. I guess with this, let's head towards the closing part. Thank you so much, sir. Throughout the presentation, the information was abundant. I especially like the pizza example. It was a very unique way to explain all these services and their differences. And in the career part, how you detailed every point from the certification project to the programming part of it, and even addressing what kind of internship should be completed beforehand. And thank you for patiently addressing to all our question. I can see all our participants expressing their gratitude in the chat session as well. We from SIS GST wholeheartedly again thank you for taking the time. That's it for today, I guess, everyone. I hope everyone took out a lot of knowledge, a lot of information, and let's move ahead with this. Sir, do you have any words?
Yeah, just concluding notes. So thanks for the opportunity. It was really my pleasure to present and interact with such a bright audience. I wish you good luck for your cloud career and your engineering journey, I would say, because I myself have proposed not to go with cloud engineering career as a direct option, right after the college. So this is where you will need to progress in small steps, but eventually when you have those small steps covered, once you take a look back at what journey you have covered, you will be surprised by the fact that you have actually got a lot of breadth and depth of different domains, and now you actually can call yourself as a cloud architect and can help solve problems for people, for companies at scale. If anyone has any questions, this is again just flashing out. This is a QR code which links to my LinkedIn and Twitter profile. Please feel free to drop links. And this is QR code or the URL for accessing the presentation with the links, because there are the programs and related links which are present as part of this particular presentation. Feel free to spread a word around social media using these hashtags, and I'm at @greatdevaks at social media. Feel free to connect with me, and thanks a lot for the opportunity once again.